Hi everyone, welcome back to our daily solutions. Okay, today's question is a little similar to the previous question as it's testing a bit on a half-life. However, this is a different type of question and requires the use of a different equation. So let's go into the question. The decomposition of hydrogen peroxide in aqueous solution is a first-order process. If 2/3 of the H2O2 in a solution of known concentration decomposes in 52 minutes at a certain temperature, what is the time taken for same concentration of H2O2 to decompose to 1/8 of its original concentration? So over here, if it's a first order process, we'll know that we can apply this formula. So this is a new formula and some schools actually do not teach it. So please take note of it as it's pretty useful in this type of questions. So over here, the reaction is C over C0. So what is C? C is the concentration after nth number of half-lives. CO is the initial concentration. Okay, so this is equals to 1/2 power n, where n is the number of half-lives. Okay, so this is only applicable to first order processes because only for first order processes then I'll have constant half-lives. Therefore, this half power n is applicable. So over here, let's sub in the information given. Okay, over here, if 2/3 of hydrogen peroxide decomposes in 52 minutes, so that means that I will have 1/3 left after the reaction, correct? So therefore, 1/3 over initial, that was 1. Okay, let's take 1 as the initial amount. Equals to half power n. So let's see how many half-lives did it take. So when you calculate it out, you get n equals to 1.58. Therefore, it took 1.58 half-lives for the concentration of H2O2 to decrease to 1/3 of its initial value. Half-life, so is equals to 52 minutes. So I divide by 1.58 half-lives, which is equivalent to 32.8 minutes, meaning it took 32.8 minutes to decrease to half of its initial value. So now I have to see what is the time taken to decompose to 1/8 of its initial value. So from 1, after the first half-life, it will decrease to half. And then after the second half-life, it will decrease to 1/4. And after the third half-life, it would decrease to 1/8 of its original value. So therefore, in order for it to decompose to 1/8 of its initial concentration, it will take 32.8, which is the time for 1 half-life times 3 half-lives. And you will give me an answer of 98.4. So this one will be the most similar to D. Therefore, the answer is D for this question. So take note of this equation over here. Thank you for watching today and hope to see you soon again. Thank you. Bye-bye.